I'm allergic to a lot of airborne allergens, such as spring pollen and molds and animal danders and hair. So I was looking for an air purifier that would work for me, for my allergies. And what I found was there's not any that can filter the air completely effectively and deliver a high airflow very efficiently. So I decided to see if I can make a better one. The goals for developing the Tanner Sedona were to make it extremely effective for its size, or powerful for its size, meaning that I can remove a lot of humidity from the air in a very small physical package, and also make it extremely efficient. A unit that's small, efficient, easy to install, lightweight is going to be better for the end customer. The Tanner Sedona took 2.5 years to develop and 63 complete unique prototypes with completely different refrigeration systems. So the end result is the Tanner Sedona is the most powerful dehumidifier packed into the smallest case volume. The Sedona is also the most efficient unit in the world without a heat exchange core. During the development of the Sedona, I realized how important clean air is for the unit, for a proper functioning of the dehumidifier so the coils doesn't get clogged up. But if you use an air filter that is too restrictive and filters out too many things from the air, then the dehumidifier is not going to get enough airflow and it's not going to work properly. So if this machine needs very clean air and the proper amount of airflow, well, humans are kind of like machines too. We function best with the cleanest air going into our lungs. The goals at the beginning of the project were to make an air purifier that can clean the air extremely effectively, removing the smallest particles from the air that can cause any harm at all to humans, make the unit completely safe, and make it extremely easy to use. So anyone can turn it on, figure out how to use the programs very easy, and change the filters very easy. It was designed around user-friendliness, effectiveness, and efficiency. So we wanted it to use very little electricity for the amount of air that it's going to clean. After researching the types of air purification methods that are out there, it turns out that there's basically 5 basic methods. There's ionization, UV light, ozone generation, mechanical filtration, and activated carbon. And out of those, only 2 can clean the air effectively and are completely safe for humans. Whenever I design something, I design them from first principles. How do we filter the air and remove anything harmful in it using the least amount of resources possible? If you had the absolute best air purifier in the world, what would it look like? How would it work? And what features would it have? What features would it not have? How do you move the air? How do you filter the air? Do we want to use UV? Do we want to use HEPA filtration? What even is HEPA filtration? So these are all questions that we had to find answers to early on and then decide how to build the unit from there. The problem with HEPA, or mechanical filtration, and activated carbon is not that it's not effective. It can be very, very effective. The problem is that they block airflow. So for that reason, we started designing the air purifier from the filters up. So we designed the filters first and designed the rest of the unit around those filters. So if you just use one air filter in a unit, you'd have to pick between activated carbon and HEPA, or mechanical filtration. And if you only have one, then you're not getting the benefits of the other. So we want to make sure that we have both filtration methods. We use 2 mechanical filters for different size particles because we want to trap the particulates in different layers. That way we can hold more and the filters can last longer. If we catch the larger particulates in the first stage filter, then that leaves more room in the last stage or HEPA filter for those very, very small particulates. And then the activated carbon can remove things that mechanical filtration can't, such as odors, or basically things at the molecular level. They get caught in little ant cave-like structures inside the activated carbon. The first stage filter removes all the coarser particles. Now, don't get confused by that and think this is a low efficiency filter. It still has a MERV 14 rating, which is much higher than a standard air purifier. But this filter removes all of the larger things like pet hair, some of the pet dander. We have dust mite droppings, pollen, mold spores, and just coarse atmospheric dust. The next stage filter is the activated carbon filter, and that removes odors and VOCs and like chemical smells. So if you have a new carpet or new furniture or new paint in your house and you have that kind of chemical smell, that is composed of VOCs. Those are volatile organic compounds and they can cause health hazards, and including formaldehyde. Formaldehyde is very common in building materials and adhesives and paints, and formaldehyde is off gas, gets in the air, so the carbon filter helps reduce a lot of that. And then the final stage filter is the microparticle HEPA filter. Now, this filter is so high efficiency, basically no particulates can get through it. It filters out more than 99.97% of particles 0.1 microns or larger. It actually filters out particles that are 0.002 microns. That's like 10,000 times smaller than a human hair. And it filters them out with over 99.99% efficiency. The fractional efficiency of this type of filter actually goes up beyond a certain particle size. Our microparticle HEPA's least efficient particle size is actually 0.1 microns, where it's still above 99.97% efficient. So why is that important? Because these small particles in the air, the very tiny particles, are the ones that pose the greatest health risk, because those particles, smaller than 2.5 microns, can get into your lungs and into the gas exchange area of your lungs, where they can then enter your bloodstream, where they circulate in your bloodstream and cause a plaque-like buildup in blood vessels, which can eventually lead to life-threatening diseases such as cancer, heart disease, stroke, and COPD. So by removing these ultrafine particles, we can reduce our chances of developing any of these diseases. We knew we wanted to use mechanical filtration for its safety and effectiveness. The only downside to mechanical filtration is that it blocks airflow. So the challenge is, how do you get a lot of air through these filters efficiently and quietly, so without using a lot of power? So it turns out if you have more area filtration media, then it's going to lower the static pressure and you're going to get a lot more air through it. Now, we decided to test this, and we tested around 30 different designs of different pleat spacings of our filtration media. So it's an accordion style, and we tried different spacings. And it turns out there is actually an upper limit. So if you have too many pleats, they're too close together and it bunches up, and then the air can't get through the individual pleats, and it actually makes worse performance. So we tried pleat spacing that were far apart, but didn't quite provide enough filtration area, and pleat spacings that are too close together. And we eventually found, for our unique filter materials, the optimal pleat spacing. And that allows us to get a lot more air through the filters. You'll notice that the filters are very thick. That's because we have a lot of media in there, over 40 feet per filter. And those also will hold a lot more particulates and pollutants. So we have a very high dust holding capacity in these filters. So these filters are custom designed. You can't just buy these off the shelf. They're custom designed for Aspen based on the specifications that we need to provide the highest volume of airflow and clean the air extremely effectively. With the carbon filter, we have the same challenge. The carbon wants to block airflow, leading to high static pressure, low airflow, high power usage. So we had to come up with a way to get the most amount of air through this activated carbon. So we came up with a pleated or an accordion style design for carbon granules. So we made different grates and put them in a frame. Now this had never quite been done before, so it took a lot of manufacturing, research and development to try to figure out how to make these effectively and make it work, because when you do something that hasn't quite been done before, there's obviously going to be some challenges. But the end result is a carbon filter that allows a lot of air through it. The carbon is also suspended in these grates, so it's held in place and it doesn't all just settle to the bottom. So when some people think of air filtration, they think that their furnace has a filter on it, so they're probably protected. Well, the problem is furnace filters are so inefficient at removing particles because the more efficient the filter is in general, it causes a high resistance to airflow. And with a higher resistance to airflow, the HVAC system is not going to get the proper air it needs to properly heat or cool a house. One of the things that we have to think about in designing a unit is how should it take air into the unit and get that air to the filters, and how should that air be discharged from the unit once it's cleaned. So there's a couple different airflow patterns, but we thought that the best, most efficient airflow pattern would be to suck air in at the bottom and blow the clean air out the top. And by doing this, we separate the dirty air from the clean air. And it also allows for the room itself to be used as a circulation system for the air. So if we're blowing the air out the top and it's hitting the ceiling and traveling across the ceiling and then eventually back down to the floor, we're creating a good circulation pattern through the room, and we're going to be able to clean a lot more air rather than taking in air, blowing it out, and sucking that air right back into the unit. We wanted the filters to be very easy to change. So the easiest way is, of course, if all three filters can be removed in essentially one step, or you only have to take off one door panel. You don't have to take off individual doors for the different filters or mess with any clips inside the unit that are holding the filters. So we designed the unit with one door. The entire side of the unit comes off, and then you have access to change all three filters that simply slide out. That was the most difficult part of the unit design, is figuring out how to easily and securely take off the doors. And actually the latching system was particularly complicated, even though it looks very simple in retrospect. In choosing a fan, it was important to select the right type of impeller blade for the fan. So in our case, with the amount of static pressure and airflow that we wanted, it turns out that a backward curve centrifugal impeller was the right way to go. So then what kind of fan motor and controls do we want? Well, we want it to be extremely easy to use, quiet, deliver a lot of airflow, and be extremely energy efficient. So there's basically two main types of fan motors out there. There's traditional AC fans, which are relatively cheap, simple, but they draw a lot of power, generate a lot of heat, don't last as long, and can create an annoying humming speed at the lower speeds because it's very difficult to control their speed. So we decided to go with an EC fan. That stands for electronically commutated. It's basically a brushless DC motor with a circuit board and circuitry in there that controls the speed of the fan essentially digitally. So With this EC fan, it actually runs a lot cooler, so it should last a lot longer, and it's way more efficient than an AC fan. Over the life of the unit, it's going to save the user a lot of money because it uses so much less electricity than an AC fan. And we decided to go with that fan design and the fan company we did because they have the best reputation in the whole world. And with the goal of developing the best air purifier in the world, it makes sense that we should use the best fan in the world. Aspen has 6 fan speeds that you can adjust based on the size of the room that you're in or according to the noise level that is acceptable in whatever situation. So if you're sleeping, you can turn it down to a lower fan speed, or if it's in a living room, you could turn it up to a higher fan speed. And if you have a high pollution event, such as burning something on the stove and your house fills with a little bit of smoke, you could turn it up all the way to the maximum for a little while just to clear the smoke. But to demonstrate how efficient the fan is, on fan speed 3, it uses only 21 watts. Now that is a very small amount of power. And on fan speed 2, 10 watts, and fan speed 1, only 4 watts. We position the fan in between the filters so that the filters can act like mufflers and make the unit quieter. But the reason we put the fan above, or essentially downstream of 2 of the filters and left just 1 above is because backward curved centrifugal fans are a lot more efficient at pulling air than pushing it. It creates a lot of turbulence when it's pushed. So by putting 2 of the filters downstream of the fan, we're going to get better airflow than if we did 1 downstream and 2 upstream. And we also designed the fan housing to be extremely smooth and direct the air from the fan upwards so that the actual molecules have less interactions and collisions to provide better airflow. We also optimized the shape of the air going into the unit and used a special product that both acts as a finger guard and straightens out the airflow vectors going into the fan itself, which cuts down on noise without cutting down on airflow. And the top of the fan bracket, the part that actually holds the fan, has ribs positioned in the exact angle that air molecules would be coming off the edge of the fan blades, and that reduces fluid friction further and cuts down on turbulence to provide more airflow and less noise. I came up with 4 distinct styled names, created a survey on SurveyMonkey and sent it to a couple hundred people. And apparently Breezium was not a good name.
Okay.
Aspen was designed function first to be the most effective air purifier. And then beyond that, we wanted to make sure that it looks right at home in every home. So it has to be the right styling and the right colors. So we went with a design that's both effective structurally and also blends in with any room, any decor, with its kind of off-white colors and dark gray. It gives a nice contrast so it doesn't just look like a bright white standard appliance. It actually looks beautiful. Whenever you're trying to develop something that is new and high performance and the best in the world, there's going to be challenges along the way, and we certainly saw our fair share of them. But we broke through and we overcame those obstacles, and after 3 years of research and development on this project, we've come out with the Aspen, which we feel is the best air purifier in the world, removing virtually every particulate from the air and leading to a lot healthier air for people to breathe. Early feedback from customers is extremely promising, and it kind of validates this whole project for us. We've had people that have had guests over that are allergic to cats and normally have to take lots of Benadryl just to go in the house. But with Aspen, they no longer had to do that and didn't have those allergy symptoms. We've had people that have severe mold allergies and have struggled with mold in their home, and once they got Aspen, they no longer had any issue. And in my own experience, my spring and seasonal allergies are so much better now that I have an Aspen running in the house. And even for people without allergies, it's kind of like a cheap insurance policy where you can protect yourself from all these microscopic invisible particles that are getting into your lungs, and over a lifetime that can add several years to your life if you don't develop a life-threatening illness from air pollution.
Anything serious for what's next, or?
Slowing the rate of entropy generation in the universe in order to reduce anthropogenic climate change.
That's awesome.
I knew like 3 of those words.